Hi, I am Joel, full stack software developer, currently working with Google. Many people face a lot of difficulties while dealing with algorithms and data structure. That's why I found interesting to give them some lectures such that they can better understand these topics, algorithms and data structure. So this is actually an introductory course to algorithms and data structure. So here we are going to introduce you to algorithms and data structure. What is actually an algorithm? Why do we need that? What is a data structure? What is the need of that? Or what also are some properties or characteristics of an algorithm, right? So let's go ahead and define some concepts, right? Actually, what is an algorithm? As you can see there, algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. Okay, that's what we can say about the algorithm. Or one can say an algorithm is a process or a set of rules required to perform calculations or some other problem-solving operations, especially by a computer, right? So you can take it like that, there's no problem. So, but the formal definition of algorithm is that it contains the final set of instructions, okay, which are being carried in a specific order. Please, okay. So let's take an example. When you want to make a coffee, there are some steps through which you go before you get the final result. That's the coffee is ready. Okay, you can see those steps, okay, those set of steps as an algorithm. You bear with me that it is finite, right? You cannot make a coffee for infinity. You should definitely stop at some point and we get the coffee ready. Okay, now let's go ahead and give some properties or characteristics of an algorithm. Actually, an algorithm has some property, okay, or characteristics. As you can see there, first, input. Okay, an algorithm has some input values. We can pass 0 or some input values to an algorithm. Alright, so actually an input here, as you are making your coffee, you can take as input the sugar, the water, okay, and we are saying that an algorithm may have 0 input, okay, as we are going to see later. First, keep that in mind. Algorithm may have 0 or more inputs, okay. Also, algorithm must have an output. We will get one or more outputs at the end of an algorithm, okay. An output when you are making a coffee is the coffee is ready, okay. That's the final result. That's actually the output. The input were sugar, water, and so on, okay. So an algorithm also must be unambiguous, okay. That's unambiguity. That means an algorithm should be unambiguous, which means that the instructions in an algorithm should be clear and simple, okay. Should not complicate something or add some steps that, okay, actually does not make an effect, okay, on what you're actually doing. That's unambiguity, okay. The fourth one is finiteness. An algorithm should have finite steps, okay. So here finiteness means that the algorithm should contain a limited number of instructions. That is, the instructions should be countable, okay. That's it. You cannot actually make something for infinity, all right. So that's finiteness. The fifth one is effectiveness. So an algorithm should be effective as each instruction in an algorithm affects the overall process, right? So, and the fifth one, language independent. So an algorithm must be language independent so that the instructions in an algorithm can be implemented in any the languages with the same output, right? That means you should not write an algorithm that is particular to C programming, to C++ programming. You should have something which is independent of any programming language, right? Those are actually the main characteristics or properties of an algorithm. Of course, there are more, but those are the main ones, okay? So as we move forward in this course, you are going to get more on that, okay? As you are going to design, analyze an algorithm. So let's go ahead and talk a bit about data structure. Actually, what is a data structure? As you can see there, a data structure can be defined as a set, okay, of as a set or defined as the group of data elements which provides an efficient way of storing, okay, of storing and organizing data in a computer so that it can be retrieved effectively, okay, as you can see there. So let me repeat myself. A data structure can be defined as the group of the data elements which provide an efficient, okay, way of storing and organizing data in such, okay, in such a way that, okay, it can be used efficiently. That's what we can say about algorithm, right? Some examples, data structure. So some examples of data structures are arrays. If you're familiar with C programming, you should definitely know what a data structure or an array is, right? So you also have linked list, as you are going to see later. You have star, queue, and etc., right? So data structure are widely used in almost every aspect of computer science, that is operating systems, compiler design, artificial intelligence, graphics, and many more. All right. So data structures are the main part of many computer science algorithms, as they enable the programmers to handle the data in an efficient way. Please, efficiency. Okay. Now that we have discussed a bit about data structure, what are actually the needs, okay, for data structure? Let's go ahead and talk a bit about the needs of data structure. Here you have this processor speed, okay? So as applications are getting complex and amount of data is increasing day by day, there may arise the following problems. Processor speed. So to handle very large amount of data, high-speed processing is required, but as the data is growing day by day to billions of files per entity, processor may fail to deal with that much amount of data, right? That's the first need. The second one is the data search. So consider an inventory size of 100 items in a store. If our application needs to search for a particular item, it needs to traverse the 100 item every time. It results, okay, in slowing down the search process, okay. The third one is actually multiple requests. So if thousands of users are searching the data simultaneously on a web server, then there are chances that a very large server can fail during that process, okay. So those are actually the main needs for data structure. Then we're going to stop there as for now. In the upcoming tutorials, okay, we are going to go into details as far as those topics are concerned. How to write an algorithm, how to design an algorithm, how to analyze it, what is a stack, what is a SQL, how to implement them, okay. Then definitely you should not miss that. See you then in the next tutorial. Bye.